Hi guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I will be your host for today's video. And for today's video, we will be deriving the Clapeyron equation. So the problem tells us to consider alpha and beta phases of a pure species in equilibrium. Show that the Clapeyron equation, which is rigorously correct for any phase change of a single pure species, chemical species, is given by this equation. So, saan ba tayo magsisimula in this problem? We have to start with the properties of the two phases that are in equilibrium. So, the four properties that are involved or the four properties na basis ng Clapeyron equation natin are these. We know that the volume of the chemical species that is in phase alpha is not equal to the volume of the chemical species that is in phase beta. Similarly, the enthalpy, which is H of the species that is in phase alpha, is not equal to the enthalpy of the species in phase beta. And likewise, the entropy of the species in phase alpha is not equal to the entropy of the species in phase beta. But they have one thing in common, and that is the Gibbs free energy, indicated by G, of the chemical species in phase alpha is equal to the Gibbs free energy of the species in phase beta. And this is where we will start, okay? This relation here. So we know that G alpha is equals to G beta, right? And we have to account for the change in Gibbs free energy. So to account for the change, we've learned that in calculus, yung change natin is indicated by D, right? Therefore, yung change in Gibbs free energy is dG. Okay? So, yung initial natin na G, yung initial natin na Gibbs free energy, which is G alpha, plus the change, dG alpha, is equals to G beta plus the change here, dG beta. Okay? And in here, we know that G alpha and G beta is the same. So we can cancel it off here. Yan, makakancel na siya. Kasi for example, if you have, let's say, 2 plus x is equals to 2 plus x. Itong 2 here, on both sides of the equation, you can cancel it off. Kasi x will still be equals to x. Likewise here. Parang wala namang nagbago and they're still equal. So you can cancel off a value or a variable on both sides of the equation if they are the same. Okay? So yan ang ginawa natin here. Therefore, we can conclude that dG alpha is equals to dG beta. And now we have to relate the Gibbs free energy to these three properties here. So how do we do that? We know from this mnemonic, this Vatag shift mnemonic here. Say the Vatag shift. Here. And in order to use this mnemonic, you have to create a box. And there's a V, and then there's an A, and then there's a T, and then there's a U, there's a G. Kaya bang Vatug, and then S, and then H, and P. Yung nasa gitna here, these are all energies. Agree? And then, kung ano yung nasa corners, they are the properties. So ngayon, ang hahanapin natin is yung relation ng dG, right? How do we relate dG to the properties in this mnemonic here? So here, actually, you have to draw an arrow that points from S to T, and then an arrow that points from P to V. So yung dG, saan ba siya nakapagitna? Sa T at sa P. So we can say that the change in G, the change in Gibbs free energy, is equal sa change in T here, and then sa change in P. And this is the temperature, and this is the pressure. And then from here, this is where the arrow becomes useful. So yung T, saan ba siya nakaturo? It is, nakaturo siya or nakakorek siya sa S, right? But since you are going backwards from the arrow, it has to be negative. So negative S dt. And then how about the P? The P is going towards V and the arrow is pointing at V. So it is positive. Ito kasi, kaya siya naging negative kasi you're going from the tip of the arrow to the tail. But this one, you're going from the tail to the tip, and that is positive. So this is positive VdP. So this is your Maxwell relation for Gibbs free energy. And we will use this to expound on this relation. So yung dg alpha natin is actually equal to the, actually pagpaliktarin natin to para yung negative ay wala sa harap, nasa gitna na lang siya. So yung dg alpha is equals to the volume of the species in phase alpha dp minus the entropy of the species in phase alpha dt. And similarly, if we're gonna account for the one that is phase beta, you know that dg phase beta is equal to the volume at phase beta dp minus the entropy at phase beta dt. And we know that these two are equal, so these two are equal as well. So we're gonna relate these two here on the right side of both the equations. So we know that V alpha dp minus entropy alpha dt is equal here sa beta naman, V beta dp minus entropy beta dp. Okay? And now what we're gonna do is to combine like terms. Lahat ng dp and may volume sa kabilang side and everything that is not that sa kabila. So ito, here, this one. We're gonna transpose this here on the right-hand side, and then we're gonna transpose this one on the left-hand side. Okay? So ang mangyayari here is mariretain to V alpha dp, and then this one positive. When you transpose it to the other side, will be negative. Negative V beta dp is equals ito, negative, magiging positive. So positive S alpha dt. And then this one, retain lang yung negative. Negative S beta dt. Okay? And now we just have to factor yung lahat ng may D here. Lahat ng differential. So V alpha minus V beta. And that one is in parenthesis dp is equal sa S alpha minus S beta dt. And dahil we know that yung volume natin and entropy is not the same, therefore it is not zero. Kasi they have a difference in value, so their difference is not zero. Kasi mag-zero lang yung difference if they are equal. But this one, for this instance, they are not. So we have to account for the changes in both the phases in terms of volume and entropy. Okay? And now what we're gonna do is we're gonna let the hypothetical change M of phases alpha and beta be equal to the hypothetical property M of phase alpha minus the hypothetical property M of phase beta. Okay? So, ang gagawin natin dito is ito, magiging change in V alpha beta. And then this one is magiging change in S alpha beta. Okay? So we're gonna write it here. You know that V, change in V, alpha beta, dp. Is equals to the change in entropy, alpha beta, dp. Okay? And now we just have to put all the differentials on one side of the equation and then all of the property changes on the other side. So yung dP natin, here, yung dt matatranspose on the other side, and if it is multiplied on the right hand side, it'll be divide dun sa left. So dp over dt is equals, dito mareretain lang siya, the change in entropy of phases alpha and beta, the difference in volume of the phases alpha and beta. What is delta S equal to? For any phase change, we know that delta S is equals to the change in enthalpy over T, right? So we're gonna replace this here. Therefore, delta S or the difference in entropy of phases alpha and beta is equal dun sa difference in enthalpy of phases alpha and beta over T. Okay, so rewriting that, it will become dP over dt is equal dun sa difference in enthalpy of phases alpha and beta over T, and then this one, we just copy here. Okay, and at what pressure do liquid and gases occur in equilibrium? It is at P sat, okay, saturation pressure. So P sat is equal to sa pressure at which liquids and gases or vapor occur at equilibrium. Therefore, dP sat over dt is equal sa difference in enthalpy of phases alpha and beta over T times the difference in volume of phases alpha and beta. And that is our Clapeyron equation that we have derived from these relations here. So that is our answer for the problem. I hope you guys learned a lot from today's video. Thank you for listening, and stay tuned for the next one. Bye-bye.